Okay, we're going to continue the last problem, and this time we're looking at those same three molecules that we named. So we had propane, we had 2-methyl-butane, and we had 1-pentene. Excuse me. Okay, we're going to do the condensed structural formula for each of these, and then we're going to do the line angle diagram as well. So the condensed structural for this one, I have 1, 2, 3 carbons, and I'm going to take them each one by one. So I have a C that has 3 hydrogens around it. I have a C that has 2 hydrogens attached to it, and then finally I have another C with 3 hydrogens attached to it. I'll be the condensed of that one. The 2-methyl-butane, start out with a CH3, and then I have a CH that has a CH3 attached to it, and since it's attached to it, I put it in a bracket here. And then I have a CH2, and finally a CH3. And then my last one here, my first carbon, has just a CH2. My second carbon just has 1 hydrogen. And then I have a CH2, CH2, CH3. Now that answer is perfectly good, but if I want to shorten it up even further, I can do so because these repeat one after the other. So I have CH2, CH, CH2 in parentheses with another 2 behind it, and then a CH3. And then my line angle diagrams, I imagine that each carbon is a node, or the end of a line, or where 2 lines combine, however we want to think about it. So in my first one, I've got 3 carbons. I would imagine that there's a carbon there, and then going up to a second carbon, and then going down to my third carbon. And I can imagine that each of these have the amount of required hydrogens that are not listed. So we're imagining by not writing out all of the extra stuff. Okay, the second one, I have 4 carbons in a row. So 1, 2, 3, 4. And on the second carbon, the second one here, I have a CH3 group. So I just have a line going up, and that would be my CH3 group. And last but not least, I've got carbon 2, 3, 4, 5, and between the first and second carbon I have a double bond, so I need to make sure that I'm showing that there's a double bond there.